Kimi K3 and GLM 5.2 are big problems for the US AI giants. But I actually want to focus more in this video about what it means for us software engineers. Now let's start with the news and what it means. Kimi K3 is a Chinese open source model that was recently released with both open weights and open source. That means that if you have your own private 3 terabyte data center, you can go and download the weights and actually use them for inference. And you also can go and read about the engineering that went into building the model. So it's pretty impressive and pretty interesting for folks like me who like reading that stuff. Now that's different than the frontier models like Claude or OpenAI, where they keep everything closed source and close to the vest. Now, one of the better practical technical summaries that I found comes from the well-funded folks over at fireworks.ai. So let me go and share some of their numbers along with some of my observations here. Now, the first thing is Kimi K3 is a very good model, like Fable good. Now, normally there'd be some qualifiers here and there, like saying, well, you should use the real frontier model for most things, but if you need something cheaper, use this other one. That's not the same here. You're talking about a competition of equals where both of them is good at different things, which is different than what we've seen in the past. Now, the caveat with Kimi is that it is quite a bit cheaper to run than Fable, but it tends to consume a lot more tokens, so you got to be careful here. Which brings me to my second point, which is that Kimi is actually better at long terminal runs versus Fable. So Fable actually starts to fall apart on very long-running terminal tasks relative to what you can get with Kimi. Now, let me give you some stats on that. When Kimi is running a short-run task, it can eat 55 turns and 1.3 million tokens versus Fable, which is much faster at 21 turns and 130,000 tokens. Now, it may still win the cost thing, but it is going to take a lot longer for Kimi to do its thing. Now, this actually reverses, though, when you look at long-running terminal tasks. This is where Fable starts to spiral. It runs up 64 turns and 1.5 million tokens, for roughly the same workload. So Fable it's actually almost too smart for its own good. It tends to get lost in thought as it gets later on. So Kimi actually has an advantage in certain things. Now, obviously, we're going to learn more as we learn more about these different models and learn what they're good at. But that comes to problem number 3, or at least observation number 3. You can solve these problems, but you need to do it with better routing. So Fireworks talks about something called Oracle, which is essentially their custom router or a router they're using that will pick the right task for the right model. So we're moving into a new era here where we're not just doing mixture of experts. We actually need to think of it as mixture of models. So if you're building a software factory, you got to figure out the sequence of robots and which ones are good at different things. This is becoming the engineering task of our era. So net, to boil it all down, the frontier models are, I hate to use the word, but they're commoditizing. And that includes hand coding, by the way, if you're doing a lot of that, unless you're doing something very like, doing medical pacemakers or something. So that means that adoption is now going to accelerate. This stuff's going to start getting cheaper, and we're going to start drowning in code because these things just spit out tons and tons of codes. So now I keep in mind governments, pundits, and other folks will try to slow down adoption, but look, free is pretty tough magic to defeat. So it's going to be tough to put the cat back in the bag. It's also not realistic to think most enterprises will be running a 3 terabyte parameter model locally, unless you happen to live in a data center or whatever. But that's not going to happen. But it does mean that the big data center hosters are going to start switching over to these models just because of the economics. So as software engineers, what does this mean to me? Well, first thing is I've got 2 jobs. The first one is I need to figure out which model is best for each task for my workloads. Okay, so I'm a factory floor manager, and I got to figure that out. Now that is going to be a process of running evals and then determining better routing. The second thing is we are entering an era of enormous amounts of generated code, and we need to be ready. And so you might see this in a lot of the literature here, is that the best teams are focusing on building evals or deterministic tests to help them scale their software factories. Now, these things, basically think of it as it's a gigantic testing harness that's going to make sure that the code that is produced by these models actually runs to spec. So now, as a software engineer, my effort is going from the writing of the code, which I don't look at as much as I used to, into the testing or the creating the harnesses around the code to make sure that's still good. So hopefully this is helpful. I would say that increasingly the moat between you and other engineers or other problems is that it's not the code you generate anymore, but how well you can validate it. If you'd like to learn more about how to do that, you can check the links below and also this excellent article from Fireworks.